Alright, good afternoon, it's Practise here, and I've got a treat for you. This is Tatooine Sunset. It's a regular Sudoku puzzle that appeared on Cracking the Cryptic a couple of weeks ago, and quite unusually both Simon and Mark attempted this puzzle, but Simon used some really rubbish notation that he just made up for this one specific puzzle, and he didn't find everything there is to find. Part of the path he kind of lost his way, so I'm going to show you how this puzzle is actually done and we're going to use normal Snyder notation, not rubbish notation that's made up for this one specific puzzle. Alright, we'll get started. There's a hidden 9-7 pair here. I should just note, of course, that if I forget my way, then maybe this is going to be a massive fail. So 7's here, 9's here, and you can carry on like this for a bit, but you won't get a number just by filling in Snyder notation at the start. So we'll fill in a few more numbers, see what we can get. What else do we have? Got 6's here. I think that's most of the progress that you can make right at the start, if I remember correctly. Yeah, not really seeing any other numbers to pop in at the moment. Of course, I could be missing something. Okay, now from this point, I looked at these 9s, and I saw they've got this relationship here. So do the 7s, but I decided to look at 9s first. So we're going to go around the grid, and we're going to colour in where 9s can go. Because we've got quite a lot of 9s, so they're quite restricted. So those are ruled out. 9s go here, 9s can go here. In the top, yes, 9s can go there. Over here, 9s can go here. So that's quite nice. Now, there's a couple of ways to make progress from this point. And given that this is a Star Wars themed puzzle, the fact that there's a nice lazy rectangle here suggests that this is intended. Of course, this is not necessarily the best way to make progress from this point, but this is what I found in my original solve. And the logic of the lazy rectangle is you've got two unique places to put a 9 in this column, and exactly 2 in this row. So there is a relationship such as if there's a 9 here, there's a 9 here, if there's a 9 here, there's a 9 here. And it works the other way as well. If there's a 9 there, there's a 9 there, 9 there, there's a 9 there. And that allows you to test these cells here and these cells here that are looking at the lazy rectangle. So if I quickly show you how it works, if you've got these two here looking across at this one, alright, then we've got a 9 here, 9 here, 9 here, and we cannot have a 9 there. And that's ruled out of the puzzle. Now, the way that Simon made progress from this point is the more sensible route, I suppose, of spotting a swordfish. Although the swordfish is, let me see, is here. Okay. It's actually quite hard to spot swordfishes that when there's so few actual candidates in each cell. So the logic of the swordfish, of course, is we've got 3 columns with 3 unique positions for a number 9, which rules all of these cells out. But I just showed you that the lazy rectangle showed you how you can eliminate that cell, and you could actually go around with a little bit more logic and get to the same conclusion that way. Alright, anyway, that's 9's done. Done, dusted, and over with. Put in the numbers. clean that up. Alright, 9s are done. We'll do the same for 7s now. 7s here, here, in here, and over there. Okay, so we've got the 7s. Now, again, I would have just used a lazy rectangle like this one. To make progress from here, but we won't do that. We'll do the sensible thing, and we'll note that we've got our lazy rectangle, and we've actually got, if we add this one and this one, now we've got a swordfish. Yep. So these cells are ruled out. Very nice. This is now a 7-9 pair in each of those cells. Those 7s restricted to 2 spots, and we've made some really good progress. The next number to do, the best way to go about this from here, is to start with the 2s. So we've already got a couple of 2s up here. We'll just go around the board, quickly mark where 2s can go. Here, I think. Here or here. I must have missed this before. That's right. I did say that I probably missed some stuff, because I know that it's not that useful for this particular puzzle, so I didn't spend very long on it. And up here, these paired 7-9s are actually useful. They're actually restricting where we can put the 2s. And it's actually really easy to spot a swordfish here. And I'll tell you why it's easy. Okay, so obviously we've got a swordfish there, but what Simon didn't tell you is you've also got a swordfish here, and you can spot either one, and it doesn't matter. They will all, either version will rule all of these cells out. So that's how to go about this bit. We'll put in our 2s, and yes, I'm aware that I'm putting them into more than 2 cells. I should note I'm not using strict Snyder notation, but neither am I using made-up notation the way Simon did his solve. Now, the next thing is to note we've got a hidden triple here. So 279 can only appear in these 3 locations in this column, and this is very important to the puzzle. So we've got 27, we've got 29. Now up here we've got another hidden triple. So 29, 27. Let's see, down here, yes, another one. 27, 29. And now we've got a hidden pair, which means we can take that out and take this out. And we've got another one coming across here. 279, 27, 29. That's another hidden pair. And this is another hidden pair. That can no longer be 2. So now 2 is actually restricted to exactly 2 locations in each cell. Let's just colour that in white for a minute. There we go. So we can actually see that. Very nice. We're done with the 2s, and we can move on to whatever number comes next. 5s, I think, are probably the next best number to go with. I've already marked the 5s down here, didn't we? So some of our work was already done. Excellent, very nice. Oh, not there, sorry. I should note I frequently make mistakes when I do this kind of highlighting. it's always good if you're doing it to just double check your numbers. Look, see, I have made a mistake up there as well. Alright, now there should be a swordfish here as well. Yes, here it is. So again, these 3 columns, hopefully you can see, are all restricted to 3 rows. That eliminates these 5s here. We'll write in our 5s. Ooh, 5's already written in down there. Write in our 5s, remove the highlighting, and we'll go for the 6s, I suppose. So we've got 6s that we found earlier. Well, didn't really find them, we just restricted them a little bit. That's done, isn't it? Now look at this, I've made a mistake here again. Alright, so 6s are now highlighted, and there should be another swordfish. Yes, we can see it right away, right here. Very nice. And we have another one going this way. So yeah, it doesn't matter which one you found, it will eliminate these 4 cells, and that's all it eliminates. So we'll fill in the 6s and carry on. Let's see, 6s. There we go, colour white. I'd say we have to do the 8s now. 8s are restricted up here. They're restricted here. They're restricted here. 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 And no restrictions here, aside from the pair that we found earlier. Okay. Well, there should be a swordfish here again. But I'm not seeing it. What am I missing? No, it's here. It's here, just a big spread out swordfish. That's it, on these rows. Okay, so these grey cells here can no longer be innate. And that's it, that's everything we learned. Put in our 8s. Get rid of that colouring. Now, what you're meant to find at this point is that there's another hidden triple over here. So there's an 8, 9, 7, 8, 7, 8, 9 triple. And then we move on. So what haven't we done now? 3s and 4s. Yes, and 1s. So I think Simon got to this point and then he just went straight into the 1s. We're not going to do that. We're going to highlight the 3s and the 4s so we know where they go. Because look at all this highlighting, what a mess it is. We need to know where we can put numbers and then we'll do the 1s. So here. 3s up here, and I should note that if we'd highlighted these earlier we wouldn't have had as many restrictions. So these restricted cells that we've got now, they wouldn't have been in existence. So it's just one of the dead ends you would have had to have taken to have then hopefully made progress to where we are at the moment. Okay, that's it. This is all the 3s. And put them in. Done. Do the same with the 4s. I've only got 2 4s. So again, there's going to be quite a few spots. Now I should note that I don't think there's anything to find with the 3s and the 4s. I didn't find anything. You might be able to take this position, spend some time on it, and eliminate a few cells here and there, but honestly, yeah, not worth our time at the moment. Not necessary to solve this puzzle. This is a handmade puzzle. You know, it's very unlikely that you're going to have to do a lot of laborious work in eliminating single little candidate cells here and there. And it's a masterpiece, this puzzle, if I haven't already said that. Alright, and finally we're going to put in the 1s. So the 1s can go anywhere where we don't have restrictions, like these. So that is virtually anywhere they bloody well want to go. And that's it. Those are all the positions. We can put a 1. Now, in this position, Simon finds a swordfish, and then he eliminates some cells, and it creates an X-wing, and then that eliminates a few more cells. But what he didn't find here is that that's not the only way to make progress. There's actually a jellyfish. If you don't know what a jellyfish is, I'll highlight it. Okay, there's our jellyfish. I'll put it in blue because it's a jellyfish. We've got 4 rows this time instead of 3. That are restricted to 4 columns. Besides that, it works the same way as a swordfish, and that will eliminate these cells from the grid. And then once you've eliminated those, that exposes this X-wing here, and that eliminates these cells from the grid. Now, of course, as I said, Simon had another way of going about it. So we'll see if we can just go back, we'll unwind, and we'll show you the other way that you can do this from this point. The other way you can do it is you can find that there is indeed a swordfish here. It eliminates these cells. It exposes the same X-wing, and then the X-wing eliminates these cells that our jellyfish eliminated the way that I just did it. So this is a absolute masterpiece of a puzzle, the way that it is designed. Without this hidden triple along the bottom, we wouldn't have a jellyfish. Without these restrictions here, these other hidden triples, we can't have the jellyfish either. So yeah, just think about what has gone into making this, because it's clearly intended for you to be able to find this jellyfish. Alright, so now we know the 1s can go in these locations. Put in the 1s. And we're done. Now it's just a Sudoku, and not a particularly tough one. So we've got a 4 here, and that will eliminate, let's see, eliminate all those 4s, eliminate this 4 and that 4. think that's pretty much it at the moment. That's the only place a 4 can now go in this cell. That's now a 1, and it places a 1 here because it's on an X-wing. That's the power of the X-wing. That's an 8. So that's no longer a 1. We've used the X-wing. So much as I hate having to remove it, we will have to remove it. Let's see, these ones are eliminated. Oh, sorry, not those ones. These ones. Okay. And the X-wing has been used. Then we've got a 6 here. A naked 6. And we've got a 8 here. That's a 1. And now that's a 5. Oh, I should say I'm incredibly slow at this. I'm not like Simon, I'm not a machine at all. Even though I know the path, you know, at this point I just have to work through it like anyone else would. Because knowing the path to get here doesn't help you eliminate all the numbers that you should be able to eliminate as quickly as you should be able to do it. So I'll just do what I normally do when I get stuck. 5, 6, 3, 8, 3, 5. We'll make progress soon enough. 3, 6, 5, 6, 6, 8. Yeah, there we go. That's what we missed. And that's no longer an 8. That's no longer an 8. That's the only 8 up there, I think. Yep. So that's not an 8. What else did we miss about this 6? I hope that was 5. Yeah, here we go. 5, we've got a 3, 4 pair here. Naked pair, whatever you want to call it. Eliminates the 3 and the 4. We get a 6 and a 5. And we get a 1. 1, 6, that's a 3. That's a 6. Okay, and let's see, our 1s were eliminated from here. This part is now done. In fact, when we place this 3, we should have known we have a 1 here. That's one of the things we missed with our highlighted swordfish. Okay, so that's no longer a 1. That hasn't been a 1 for a while, neither is that. As you can see with our highlighting, it's just showing us where all the 1s are. Or, you know, where they can still be. Now, at this point, what do we have left? We've got 3, 4, 5, 8, 8, 3, 8 pair. So we'll use that. 3, 8 pair sees this, makes a 9. Makes a 7, and this is going to unwind all these 2, 7, 9 triples in a second, I bet. So 9, what have we got? 2, 7, there we go. 7, 2, 9, 2, 9. So we've unwound those. 7, 7, 2, 9. 9, 7, 9. 279. I think that's it. No, we're missing one here. I think that's the last two. Oh no, it's not the last one, but it's certainly one that goes up here. And what have we got down here? That's a 2. That's a 4. Yeah, as you can tell, I'm incredibly slow at this process. Got a 3, 4, 5 triple. That's a 6. 3. I mean, if you can spot the triples as they occur, you'll be much faster than I am. If you can spot them easily. 3, 6. 3, 4 pair. 3, 4 pair here as well. That's a 5. What are we missing here? Oh, that's a 1. Yes, there we go. So the last remnant of our jellyfish has now been used as well. And it's left us with a naked 4, a naked 3, which unwinds at 4. Over here, 3, 4. What's that? 3, 8 pair. Nonsense. It's 8, 3. Got a 3 here. That's the 8. That's the 5 then. That's better. 6. Yeah, sometimes you do get a bit blind. 7. 5. 3. And if I've not made a mistake, that's an 8. And that's the correct pathway. Following the logic. And thank goodness I remembered it correctly. Alright, I hope you enjoyed this video. And I hope you enjoy Simon and Mark's videos. They're excellent. Alright, bye bye.